Hello again. Okay, cool. So yeah, as I told you in the presentation, so we're in to try and rebuild the sound, like the sound waves effect, and actually I might not use this one. Let me know. No, maybe. The thing is, I'm gonna need both my hands, and I don't really need the mic. Can you hear me well? Or? Okay, cool. Sorry about that. Yeah. Okay, but in the meantime, do you guys have like, basically I'm gonna use like a 4.46 version, which is the latest public version of Lens Studio. But honestly, it's fine if you've got like an earlier version because we're not using any particular features that's needed like from the very latest version of Lens Studio. So yeah, even if you use like 440 or something, it should be fine, I think. Let me know otherwise. And do you guys have the project already? Yeah, you're cool. Okay, so yeah, I guess we can just open it and you can just have a look what we've got in the project right now. It's like basically all the effects that I showed you in my slides, or at least yeah, most of them. And yeah, like today I'm just gonna basically spend time on the sound waves effect, which is just one specific material. But feel free, like later on, if you want to just have a look at the other materials, like they might be interesting. Like the light rays one, for example, is quite cool because it's just a way of doing fog. It can be used for many things, but like light rays and fog and stuff like that. It's just a cheap way of doing that. And so yeah, feel free to just have a look. In the project, we've also got like one VFX system, a very simple one. It's like the sparkles one that kind of propagate at the very beginning. So the same, like the setup of this one is fairly simple. Is it working? Yeah, cool. Thank you. And yes, but yeah, like if you want to have a look, like very simple VFX system, and yeah, you can have a look at all the individual assets. But yeah, as I said today, the focus is on the sound waves effect. So yeah, let's see the preview actually. If you go in the preview window and you can go just here and basically want to use a specific video, but I can't find it for some reason. So just let me have a quick look. I don't know what is. Sorry, just one sec. Oh yeah, that's. You should have this in the. Well, yeah, you have it for sure. In the hierarchy of the project we sent you, like there's a preview folder, and in there's a vinyl preview web media video. And that's the video we want to use as a preview for the project, and it'll just be easier to visualize what we want, which is like the different effects and the reveal. So yeah, that's yeah what I showed you, all the effects playing at the same time, the reveal effect. And yeah, feel free to just go through one by one when you have time. But at the moment, let's just hide pretty much everything, apart maybe from the helmet. Cool. And there's a folder in the hierarchy here called Materials Visualization. And in there, we've got a simple plane. Yeah, most basic geometry we can have, just a plane. Because as I say, like this effect, the sound waves effect, is just using like a material. Like we don't need like a plane with like crazy poly count or anything. So yeah, just a material. And I guess it'll just be a good way of showcasing like how powerful the material editor in Lens Studio is. So let's go to the inspector. The material we want to have a look at is called Sound Waves Scratch, because we're going to build it from scratch. And also, like, yeah, feel free to interrupt me if like I'm going too fast, or if you just have a question about anything. Yeah. Okay. Cool. So yeah, at the moment what we're gonna do is we wanna go inside the sound wave scratch material. So you can find it either in the resources, or like if you go back in the hierarchy, pick the sound waves scratch planes that you can see there, and then from the inspector you can trace it back to the sound waves scratch. So you all see the material at the moment? Cool. Okay, so what we have here is basically, we've got like the basic structure of the material. I've done this because basically rebuilding node by node kind of takes forever, like a bit tedious. So like most of the parameter nodes, they're already there because it's just easier this way. And yeah, we've got the basic structure. So like first we're gonna build a group of nodes that's gonna visualize like the circular waves, concentric circles. That's the core of the shader really. And then we'll feed this group of nodes in the reality warp group of nodes, and this one is gonna like its role is gonna be to like deform the video feed to get this quite distinctive look that we're gonna get at the end. And then finally we're gonna have like a radial mask that we're gonna use for the alpha, the transparency, like to blur the edges of the plane. Okay, so let's start. First, we're gonna grab the UV coordinates of the plane. And from there, we're gonna feed it into a distance node. So with these two nodes, what we're gonna do is basically create a radial gradient. And to do this, like we go inside the distance node, and here we're gonna put 0.5. So yeah, the UV is like from 0 to 1 vertical, 0 to 1 horizontal. So we want to go from the center of the UV. So that's why we're gonna grab the distance between 0 and 0.5. So there we go. So yeah, we can, in order to visualize what we're doing, every time we can just plug it into like the RGB node in the construct vector, or you can plug it straight in the color node of the shader. So this way we can have a quick look at what we're building. So here, yeah, just a radial gradient here from black at the center to white on the outskirts. Cool. From there, we want to use like a multiply node. And we're gonna grab this amount node parameter. Yeah, quite important. Well, I guess you know that, but maybe it's important to say like it's always important to name your parameters and expose them so that yeah, maybe the developer can use them later on. And to do this, the title is important, but also the script name. Again, for the developer to, for example, access it in some scripts later on. So always important to name everything, a bit like in Photoshop or all kind of softs, really. Cool. And okay, so basically after that, from the multiply node, we're gonna grab a sine node. So we're basically calling a sine function and feeding like all the rest of the group in it. And yeah, let's grab the results of all this and plug it in there. At the moment, nothing, it's normal. It's because like the parameter must be at 0. So let's grab the material. You need to go back to the inspector and to be able to tweak the values of the different parameters. So here, the amounts stay at 0. So I guess we can go for something like 60. So 60, this gives us that. Basically, by multiplying like the radial gradient by a value, we're taking the sine function and we just increased the frequency of the sign in order to get all these circles. So you need to get quite a high value, like so 60, to get like only a few circles. Later on, these values sometimes like become a bit crazy. So like later on, what you might want to do is you can always plug like a remap node between the parameter and the node that follows, and the remap allows you to basically brings it back to more like normal values. So like here, for example, in the float parameter, I'm from 0 to 100. And with the remap node, you could say, well, 100 is now 1 or like 5. And then the slider would be a bit easier to play with because we could go from 0 to 5 or something just shorter. But yeah, so honestly, it's already pretty okay. Like it's coming together okay, but we want them to move like these circles. So in order to do that, we're gonna grab this. Let me know actually. Like, is everything going well? Yeah, everyone follow. Okay, maybe I'm going a bit fast. Sorry about that. Feel free really to tell me if do you want me to go back to some step or.
Could you just please zoom in a bit more?
Yes. Okay. Sorry about that. Like the layout in Lens Studio is a bit tricky here because in order for everything to be big enough on the screen, we need to use like a really small resolution. So yeah, it's all a bit tricky. Like yeah, sorry about that.
What was the value of the float parameter again?
Like which one? The amount? Yeah, the amount one. Like at the moment, I put it on 60. 60, but yeah, honestly, what we want is just like quite a lot of them, but you can put like a bit more, a bit less. And cool. So is it okay at least for this group of nodes? Do you want me to zoom in even more, maybe? Okay, so maybe I can summarize a bit. First we've got the UV coordinates plugged into the distance node. This distance node has a secondary set of value 0.5, 0.5. So this is to get the radial gradient. These two nodes we're feeding into a multiply node, and this multiply node is connected to the amount parameter. Is it all right? Or? After multiply, we're feeding into the sine node. So here there's no value to fill, just a sine node. And you should get like these black and white circles. Again, the amount needs to be like something like around 50, 60. And is it okay for me to move to the next part, like animating them, or? No? What's the... Yeah, well, maybe I can have a look. Okay. Are we guys? Are we doing fine? No, sorry about that. There's an issue that we didn't realize. It's like the glow. There was some glow left. For some reason, we tested it in public with same version as you, and we didn't have any issue with the glow. The Windows. Exactly, at the end. Yeah, Windows. Damn. Yeah, of course, that makes sense. Okay, well, sorry about that. How bad? So you should all have the circles at the moment, black and white circles. Cool. So let's continue. At the moment, we can see like the circles, like they're quite softish in a way. We want them to be much sharper. Well, actually, we want to be able to control at least like the sharpness. So in order to do that, we can grab this thingy from the sine node, and we can plug it to a multiply node, in which we're gonna plug the softness node. let me know if you don't see like well. Right now I'm gonna try to think about like zooming really on the nodes that we're using. So for the softness, let's have a look at the parameter. Oh yeah, true. I need to, every time I'm doing that, I need to think about the fact that I need to connect again, because we're creating these new nodes. We wanna connect everything again to the final shader node. Again, I think we don't have anything anymore because this parameter.
Du coup, tu peux mettre à quoi laquelle value
Pardon, lequel?
J'ai pas vu à quoi tu le plug
Le multiply à softness. On connecte à softness et après le tout, on reconnecte toujours au constraint vector qui est tout au bout du shader. Okay, so right now we're just tweaking the value, like the softness parameter. So we're going back to the material in the inspector, and this softness parameter that we just plugged in, we're gonna set maybe like a 0.4 softness value, and I guess. Oh, actually, I'm sorry, I just made a mistake. We don't want the multiply node. Sorry about that. It's my bad. Like the sine node, we actually want to connect it to a power node, which is not the same at all. Power node, it's gonna allow us to control both the thickness and the softness of the circles, both at the same time. Okay, so sorry about that. So power node instead of multiply node on this one. Sorry. Oops. Okay, let's see. Yeah, okay, so that's good. So again, like this value, like the softness value, I think 0.4 for now is what we want. Okay, so this is cool. That's basically at least the black and white version of what we wanted. One last thing, we can go back to where we were, like around the distance node. And basically we want the circles to move now. It's quite static, so we want to have a bit of an ability to control like the motion. So the speed parameter, we're gonna plug it to between the multiply and the sine. For example, we're gonna make a little bit of space to plug in a wonderful subtract node. Okay, it's getting a bit jammed in at the moment because not enough space. So yes, we went back to the multiply node that was right after the distance node, in which we plugged the subtract node. And this subtract node is going to receive like the speed parameter. And this subtract node we're now feeding into the sine node. So again, a new parameter to play with. Cool. Let's go to the inspector. Speed, we're gonna put something like 5. And it doesn't work. Strange.
You need time, no?
Exactly. Maybe Adrian, you wanna come over and take the spot. I think you do a better job. Maybe. You're right. Exactly. It's actually a good way of seeing why it was not working. We need elapsed time to basically it's bringing this value of the time just going through. And so between the parameter and the subtract node, elapsed time, and now it is moving indeed. Thank you, Adrian, for your participation. Cool. Do you guys have this working on your side? Or? Sorry?
It's moving backward, family.
It's probably because you put like either like a negative value or you added a add instead of subtract. Actually, it's interesting to know that in the softness parameter, like in these parameters, you can always enable like a min and max value, where you can set up a slider, and basically here we could, like the minimum value is 0 at the moment, but it could very well be like -5, and then it gives you a chance of like going backwards basically, like so -5 would go the other way, inwards. That's not what we want for this effect. Could be useful one day, who knows. 5 going outwards. Is everyone all right? Someone needs help, maybe? Let me know. Okay, it means that we can move forward. Great. To the exciting part. Now we've got like the skeleton, basically like the drawing, the shader that we wanted, and now it's just a matter of mixing this black and white shader with the video feed that we're grabbing from the phone camera. So in order to do that, we're gonna take like basically the result of what we've done. We know the power node. This power node we're gonna feed into a multiply node, and in this multiply node we're gonna put like a warp strength, like the warp strength parameter. Yeah, good call. So yeah, remember like we ended on the power node to control the thickness of the circles, and we are now like putting the result of the previous group into a multiply node, and this multiply node is receiving like the warp strength parameter that was already there. And from there we're gonna put like an add node in which we're gonna grab some screen UV coordinates. Great. And all this we're now plugging into this group of nodes, which it's basically a texture. And like the result of this, we're gonna grab it and plug it into the construct vector node. And then we've got this wonderful glitch. Amazing, that's what I wanted. No, like, it happens. This happens, I'm sure you've seen it before. Like, this happens where you're missing a texture. So you want to go to the inspector and go to the device texture, the texture parameter that we just set up. And then we're going to reference the screen texture, really handy thingy that you can call in the resources. Like, you can, if you need it, like you can just call it from there, and screen texture. Really cool. It's like basically calling like the video feed from the camera plus all the assets that you already rendering to the render target, to the scene. So like because basically with the sound waves I want to deform the video feed, but also like the previous visual that I made. So like the cover, like the cover of the vinyl, like the helmet and stuff like that. Basically I want to deform them as well. So the screen texture is perfect to do that. It's like this video feed that contains everything that we've done previously in the project, basically. Okay, so now that okay, I need to reference the texture again. Screen texture to put in the texture parameter. And now, what's happening? Oh, of course, nothing, because we need to go back to the inspector. And by default, like all the parameters are at 0. Warp strength, I think we can try something like 0.5. Maybe, let's see. Oh, I don't know why. I think it's worth saying that like when you've got like only one display, the layout is quite a lot of windows to fit in. So it's always better if you can to have like 2 monitors, because here, for example, when you do this kind of shader work, it is really handy to be able to see the preview live. So this way, like you can see live basically what you're doing, like all the changes that you're making in the material, and you can have like a direct feedback, which is really helpful, of course. Cool, like so suddenly magic happening. This is really nice. Let's try and put the preview there. Cool. And that's basically it. In like really now it really boils it down to this value called warp strength, and it's basically like you can control the, like how can I say, like the power in a way that you've got with how much like the video feed is going to be deformed. So like when you've got like a really low value, we have something that's more like a ripple, like a nice gentle water ripple kind of. And if you increase the value very quickly, it can go quite trippy, and, which is cool as well. And I think for the project, basically this is really empiric, like it really relates to how direction, like it's what you decide is right. So I guess like this one is quite cool, but I like it when it deforms a bit more, and it start to grab like some colors from elsewhere in the screen, so that it just gives everything a bit more contrast. Maybe you can bring the you can go back in the hierarchy on the left, and for example, at first we disabled all the other assets, but we can go back and, for example, enable the asset called album cover. And it's cool because you can see that like the sound waves also, like as I told you, it also like deforms in the refraction. You can see like the visual of the cover that we're adding virtually. The sparkles as well, for example. Let's restart the lens to try and see the sparkles. Yeah, and yes, I think that's. I might have taken too long. So, like, should I take time to do the alpha transparency part, or are we cool? Yeah. Okay, no, I can just tell you really quickly that basically, like, there's always like here in the construct vector. No, what we've been doing is just the RGB, the color side of the shader. But it can be a bit problematic in some way. For example, like the plane, we've been putting this on the plane, and as you can see here, we've got some like really hard edges on the plane, not ideal. So like if I had more time, what we would do is basically we need to set up something for the alpha. So like the bottom red part that you can see here on the construct vector. So first RGB, the color side, and then the last bit is like the alpha side. And in there, I would have just put like basically there's a really handy node called a radial gradient, and by setting up some radial gradient, you can just like create like a bit of a mask that's gonna basically say to the visual, okay, like when you arrive at the edge, you just vanish in a nice, cool way. Let's see if I can make it happen really quickly. Just you can go back to when you need transparency in a material. It's important to go to the inspector. You go in the material in the blend mode by default. Like a blend mode is set to disable. We want to have like a normal mode to allow for like some transparency. And is it working? Yeah. I think it's working, yeah, basically. Yeah, now I'm able to control like the transparency of it, and the mask that I've been making here is basically like the circles are only appearing not at the very center, but just a bit further away. So at least we've done this because like we wanted the circles not to affect like the visual of the helmet. So, at least the helmet is clean, then the waves starts like after the helmet, and then at least like instead of hard edges, we've got like a smooth ending like on the edges. And yes, I think that's it for me. Like maybe let me know, like did you guys manage to do at least the deform part? Ouais. Ok, cool. Je peux aider en français, oui. On s'en fout.
Hey.
Now, Adrien.
Hi. Hi, Adrien. Hi, Adrien. Okay. I'm Adrien, and we will see about face lens. And so I will ask you gently to tick off this marker in the object panel, and tick on the face lens. To make it even better, in the preview, we will switch to front cam, like this. You can have your face, or if you want, like this. But I'll do like this for me. And I did plenty of stuff in studio, but we will see only the split on the helmet for one helmet, because it's the same for both, but in opposite. But for one helmet. So I'll ask you in the raw sources under 3D directly at the root of 3D, there is this material, which name is TB, like one of the Daft Punk band guy, crystal and workshop. So you can double click it. This is the material of the mesh you see in the preview. Let me see if I can. Yeah. So if you are, make sure you are inside this this material here with workshop in caps, and we will go right at the bottom of this material. So you see this is the full material. You can see full material by pressing F on your keyboard, and you can select the end of the node branch and like Shift F, and you can zoom in like this to zoom. And so let me check, because not in a lot of space. So what we want to do is to discard part of the helmet, and so if you remember this UV I've told you in the presentation, this is where we will use this second UV on the right, UV unwrap, UV cords, to make this effect. So we'll start with a discard node. Don't worry, this one will be shorter than the precedent. And what is the use of this node is to everything that is above the value here, the Boolean value, will be discarded. So we plug the color inside the first input, and the output. Let me check my notes. How I did this? I forgot already. We will go first and actually create. Sorry, with the tab key. You all know the shortcut, right? Tab key, and create a float parameter here. And let's name it, because it's a good practice to name the parameters. So how did I name it? This guy split. Let's call it split. Translate. I invented this name myself. I think it's quite original. Oops. And let's put the same script name. Sorry. This is important because this will be exported, and we will accessing it via script. So this is this name we will access via script. This one.
Excuse-moi, comment tu renommes?
Ah oui. So if you don't see this window, right?
No.
Yeah. So you have to take this small arrow here. It's a bit hidden. It's one of the hidden stuff in Lens Studio. Like this, and you can close it dragging like this. So this parameter node it should be set up for you all, right? Fine, not so complicated so far. And So this parameter node gives a value, and actually what we should do now. Open again the preview of the parameter node, but because we will enable minimal and maximal, so this is to set like a slider in the inspector. This will show us a slider, and as a minimal value, we'll put -1. I will explain why later, and let's let the maximum at 1. Done. So what we could do now, we could put this inside the Boolean input of the discard node, and let's actually branch discard node to the shader node. So if you have the inspector panel beside you, like here, you would see now here the split translate parameter here at the top should be. Actually, you know what? I think you can just as a note, you can order your. I remember. Yeah, you can order your parameters here. You see, this is to 0, so this is at the top. But if you put like 10, it will be up, right, under. Sorry, don't do what I just done, but just to tell you, you can reorder your parameters here like this. So let's leave it to 0 because it's good to have it at the top. And so if you do something here, it's completely disappear, of course, because you have to plug the UV coordinate of the helmet. Just here, so we will. Let me think again. So we will create the UV coordinate of for the surface for the helmet. We will input this inside the shader, and after this, so we will create a isGreater node. isGreater, like this. So this says everything. Okay, it's a bit tricky to explain it, but let's say I will plug the parameter node to the how I could say. So everything that is I don't know where I'm going now, but so okay, let's just do it. You'll see. It's better to see. You plug the isGreater node inside the discard node, like this. Oh, what's happening? Very strange. So, does anyone knows what's happening here? Yeah, let me show you. How do I switch? Why? You see, you have two UVs coordinates. So it refers to the first one. So here you have to increase of one index to refer to the second one, second UV coordinates. And now, when you change the value of the split coordinate, it does a split like this. So 0 is at the middle. Actually not. Strange. Sorry, I forgot just one thing. Because we need to be to 0 to be at the middle. So we will. Does anyone knows what should we put between the parameter? I would put a remap. So maybe other possibilities are possible. Everything is possible in multiple ways, but like this one. So remap, actually, it's already set up. So you have the input value -1, and input max value is 1, and at the out of this node, minus is 1. It's 0. Sorry, maximum is 1. So now we should have this. When it's 0, it's on the middle. 1 is full. 0 is completely disappearing. Yep. So that's it for this part. Sorry, maybe I was quite fast. Really? It was fast? Oh, sorry. My bad. I thought it just, it's just there is 5 nodes, but actually it's. what I just said before is so this surface UV chord should be index 1. This goes into the greater is greater. So if you want to explain, so what it's doing, it's the value goes from 0 to 1 when you slide the parameter, so it's sliding the value on the x-axis.
How did you switch the UV modes? I missed that part.
Yeah, here. So inside the UV chords, you enter the preview, and here, 0 is the first UV chord, 1 is the second one.
Yeah, got it. Thanks.
So this has to be set in your FPX, I mean your asset before importing in Studio. And how to make it interactive. So this is a script part that Lubna will talk about. And but if you have any other questions, I hope not. No, I'm kidding. No, but if you have other questions, because I set up all the the planes, maybe you were very curious and look inside here. You could activate in. I hope actually everybody's okay. I guess it's yes. So inside under the head binding in the fence lens part, you could activate the secondary helmet, like here. And so we worked on this sorry, how to call it, render mesh visual, but we could now deactivate it and activate, because this was for the workshop, and we could reactivate the one we use for the rest of the workshop. So just as a note, these were not the meshes we used for the face lens. Maybe you understood this, because we can't share it with you. Sorry, but stay, because it's still nice. So this was from a library, but this came free. Those helmet. I had to tweak it a bit. I had to add some thickness. I had to re-UV unwrap. Yeah, but these are different from those you can see on the Daft Punk lens. Yeah. So at the moment there is no interactivity, because Lumna has to do the script to make it look interactive. So yeah. Is there any question? This was simple, but interesting, I hope. So I will pass it on to Lumna, our script engineer. Merci.
Hi again. So we'll try to add the interactions that we discussed earlier through the slides. So for now, now that you did all the, split in a system with Adrien, we will see how we can make it move. So if I put back the split, we can see that we have the glow, we have the split in the middle, and we have this this cut in the middle. For now, we'll just go ahead and deactivate the glow, the element in the middle, and that's inside the orthographic camera font. And it's the full frame region 0. You can just remove it for now, and we'll come back to this later. So basically, if I go back to the materials, if we open the TBA crystal back, for example, and we play with the split translate, we will see that it moves from an end to the other, and 0 being the default value and the value where the split is in the middle. What we're going to do is try to find a way to move this split translate parameter using the rotation of the head, as you could see on the final experience. So to do this, we bear in mind that we have this, and the name that the script name of this parameter is split translate. So this is what we're going to access from the script. So let's create a script file. So let's go to the script folder. We tend to always put all scripts in the script folder, but I guess this is something you're familiar with. So let's call it splitter, and I will attach it to split planes because that glow in the middle is the result of moving the split planes. So we'll just put it here and we'll see how we can benefit from this later. So we create a script component, and let's attach the, for now, empty script file splitter. Right, so the fact that the helmet is following my head is because we have put everything, every mesh related to the helmet as a child to head binding. So head binding is basically the key to having an element following your head. So this is what we're going to use to retrieve the rotation of the head and the position. So let's go back to splitter, and we're going to create an input. So basically we're writing JavaScript, and with this decorators that are specific to Lens Studio, we can create an input. So my input is going to be the component, the head component. So I can start typing head, and I have an auto-completion that gives me the component.head. And let's call it head. You can call it whatever you want to call it. So once I add an input here and I go back to the script, if I save, I can see the parameter appear. So let's just drag this head binding and drag it here. Right, so what we want to do is, in real time, change the position of that split. And basically, in terms of Lens Studio, is doing it frame by frame, is what we can call real time. And to do so, I can just lean on Lens Studio using the events that it has. So we can call it an update event. And here you just need to call script, create event, and Lens Studio takes care of creating an update event. Once you call it update event, as you can see, you can have different events. You can have mouth open, mouth closed, etc. For now, we're just going to use update event. We won't need anything other than that. And once you create your event, you can bind it to a function. And basically, each time this event is triggered, which is actually each frame, frame by frame, it will execute the function you bind. So let's call it update split. For now, it's not defined, so it does nothing, but it's even going to break. But this is the way you bind a function. So let's create a function called update split. And basically, this is where we're going to do the work. And to get a better grasp of what the head component allows us to do, we can start printing. Just to try, let's print what the head has as a rotation. So to do so, we access the head input by writing script.head. Then we access the transform. And basically, this transform is that object that has all the info about the rotation, the position. You can get them through the transform, and you can also set them through the transform. So once you get the transform, you can get the local rotation, which is what we're going to use. And if we print this, and I need to add the logger. Wow, that's unexpected. Wow, okay. How did you manage to handle this, Simon? Yes, right, so let's add it here. Oops. right here. So let's clean, and then if I save, yeah, I should start seeing the values being printed. So, well, now we only get the first element, but just you can see that when you move your head around, you see all these numbers. Yeah, sorry if it makes you dizzy, but we'll stop printing stuff now. Okay, one thing I do not recommend, and I did here, is getting the transform inside the update event. You don't need to do this at each frame. You just need to do it once at the beginning, and you can call it the head transform. And you can do it once, and that's it. You can access the rotation in real time, because this is quite, it's not optimized to do it at each frame, and you just need to do it like this. So it will just do this, like this, and call head transform, and it doesn't change anything. Now we don't want to, obviously we don't want to print. We want to get what I explained earlier, which is the projection of this rotation, that is theta, on this axis. So it's the sinus of this. When you get the rotation, it gives you what we call a quaternion, which is like a tuple with 4 elements. And what you want, you want the Euler angles. And once you get the Euler angles, you just need to get the rotation around the y-axis, which is this axis, which is this, and compute the sinus. So it's pretty much straightforward. We can call it, we can define a function here. There is split position, and we set it to 0 because this is the default value. And here we can just compute the sinus of the local rotation, but we get the Euler angles. Ooh, again some. Yeah, two Euler angles. So just a simple conversion to Euler angles, and the angle that is around the y-axis. So once we get this, we basically get the projection at each point, at each frame of my rotation around the axis, which is this rotation. So now that we have the split position, we want to change the material that we saw earlier. So we need to get those materials as inputs. Don't hesitate to stop me if something is not clear. So we have actually 4 materials. So we're going to create a list of materials. And to do so, you just create an asset material input and put the brackets so that you get a list. And then we can call it helmet materials. Again, once I save, I get the list here. I will create 4 of those because this is what we have. And one trick is that you don't need to put your material, click again. You just click once and you can select the 4 and it will just populate the fields. I know it's called crystal, so you can look up using crystal.
I think Adrian had the question.
Sorry.
I just wanted to ask if you can make the code window bigger.
Okay, I think it's not moving.
Oh, you can't.
I don't know why. Sometimes it does, sometimes it doesn't.
Undock it, maybe?
Sorry?
Undock it.
If I undock it, like you mean?
Take where script editor is written.
You want to take it away from the? Yes, but it's so that I can. All right. Yes, we can do this. You just wanna. Yes, nice. Yeah, let me put it here so that it doesn't. Whoops. Yay. Okay. Sorry. Yes. Yes, it's not the best. Actually, I'm using Lens Studio. You can use VS Code, but it's the only thing is that when you refresh, you don't get the preview. And we have only one screen, so for the sake of the workshop, let's bear with us. Yes, now that I have the helmet materials, how do I access the split translate parameter that I saw earlier? So it's pretty straightforward. When you have a material like helmet materials, you can just, okay, well, let's create a function. Update split on materials. And as an argument, we will pass the new split position. Oops, sorry. Split position. And here we will just do a for loop on this list, which is, so we access the input helmet materials for each, and inside we can define a function. Since we're iterating over a list of materials, we can call the element material that we get. And it's, again, pretty straightforward. Your material has always a main pass object. So this is like a constant object that you have in all your materials. So once you access main pass, there you can access all the parameters that you created and that you named, using the name that you used as a script name. So our name is split translate. And here I can just put my new split position, because this is the projection that I think will make the split go and span over the helmet. So if I save, I will have nothing appearing because I haven't plugged the materials yet. So let's go again, and we can just type crystal, and you'll get the four of the materials. So I'll select them, command and select, and then it should be, again, this won't work yet because I haven't called the function yet in my update split. Again, the update split is this function that is executed frame by frame. So let's call update split on materials and give it the split position. And now I can see that it's moving around my head. Maybe this is not fast enough. We want it to be a tiny bit more visible. So let's create a parameter that we will be, it will be a float, and we will call it the speed. And let's set it to, let's try 10, maybe 10 will do it. And then here, before, at the same time that we're computing the sinus, let's multiply it by this factor, and it will just make it quicker. Okay, now I think it's way too fast. So let's set it back to, let's say, the one we used was 2, so let's use 2. Okay, it's not working, and that's because on Lens Studio, once you set a default value, it will be the default value even if you change it from the code. And so you need to go back to your inspector with the script, and there you will change it to 2. And now I think we can be quite happy with this. So yeah, that's for the split. Anyone stuck on anything? Cool. So now if I re-enable the glow, obviously it doesn't move because I didn't do anything to move it. If I, like Adrien showed you earlier, this glow at the middle is the result of these 2 planes. For example, if I go to the one with, sorry, this is a pain. Ooh, okay, I have 2 script editors now. Yay! If I go to the split plane on Thomas's helmet and I play with the, oh, actually it's frozen. It's frozen. Okay, let's. I think it's better if we do it like this. Okay, sorry about this. Oops. Okay. So yes, if I change the value on x on this plane, we can see that it moves. So all we want to do is make this same planes follow the same position, split position that I created here. So we just need to create a function that makes these planes move. The good thing about creating the script here is that we can get this object with the split planes just by calling script get scene component. So that's what we're going to do. So let's call them the split planes, and then we can do get scene object, and that will give us the planes object. And again, we need this transform, as I said earlier, to change the position, rotation, etc. We need the transform, so let's call it the split planes t, and this will be split planes get transform. So now that we have this, we can get, set, rotation, whatever we want to do with the rotation position. Right, so now let's create a function that we call update position on x, or we can call it on x, or we just call it update position. So this will have two arguments. So the first one is the transform, so the transform of the object I want to move, and then the new position. So this split position that I want to use to move my planes. So here, the way we're going to be calling it is update position on x, and we'll pass the split planes transform that I just created and the new split position. So I compute it here, I change the materials here, and I update the planes here to follow exactly the same position. So once we have the transform here, we can create old position, because what we want to do is change the position only on x. So we need to keep the y and z from the original position. So we will still need to keep somewhere the old position. So let's call it old position, and then we get the local position from the transform. I do a quick test to avoid doing work for nothing. I can just look check if my old position on x is different from my split position. And if it's the case, I do the work, otherwise I don't need to do anything. So the new position will be set using transform, set local position, and here the set local position gets a vec3, because the position in 3D is vec3. And then here we can do new position, because this is my new split position. And the rest I keep the old. So old position y, old position z. We don't need to move anything like on those two axes. So if I save, I have an error somewhere. So split planes t, update position, tac. If I check my inspector, okay, it's not defined. Should I use a different name? Maybe I use a different name. Okay, update position on x. Okay, update. So it's going to be update, right? Okay, cool. Right, okay, now it actually seems that it doesn't move. But when we saw this first, we thought it didn't move. But we actually need to have a factor, and it's just an adjustment factor. Pretty straightforward. I struggle with this script editor, I'm sorry. I'm not used to a single window. Okay, so just a simple constant adjustment factor that we're going to set to 10. Obviously this 10 we got it after lots of testing. So let's do adjustment factor and multiply the new position by it. And let's see. Okay, now it's moving at the right rate. Actually, since the two helmets are not exactly the same, we found that we needed to have two different factors for positive values and negative values, but for now we'll just stick with this one. So it's moving. But as you can see, we have the planes actually moving, but they're not adapting to the size of the helmet at this position, for instance. And to do so, Adrien had already thought of this and created earlier these two planes that if we move them on X as well, you get the right size. We don't need to get into the details of this because this is 3D, but all what we need to know is that we need to move them at the same position as well. So it's going to be quite easy because we're doing exactly the same thing that we did with this transform with these new planes. So I'll create two new inputs. I'll keep them next to the materials. So it's just a scene object because that's what we're getting here. We'll call one the TV black plane. That's how 3D artists named them. And the same thing with the other helmet. So GM black plane. Again, I'll do the same thing I did here. I'm just going to grab the transforms. Let me call it the TB black plane T. And here is going to be TB script, TB black plane. And I'll do the same here with the other helmet. GM black plane T. And yeah, just quick. So once we have those two, we can just do exactly the same thing and update their position in X as well so that they follow the same position. Right, so here is going to be, TB black plane T, TGM black plane T, and obviously the same position applies to the three because we want them to be on the same position. If I save, it's not going to work because I haven't plugged my arguments yet, my inputs yet. So let's plug them here. I like to drag and drop, but you can look them up and add them from the input field. And now it works. So it's it's following the same position as the split. So it's actually doing a projection and the right cut at the right position. So yeah, I hope everyone has got the same result. Any questions? Ah, encore, pardon, désolée, j'aurais dû avoir deux écrans, mais c'est pas possible. Be bigger, even bigger. Tac. Ok, je vais essayer de carrément prendre tout l'espace. Tac. C'est vraiment un nightmare. En fait, on essaie d'agrandir. Ah, ok. Ok, second degré. C'est du second degré. Ok. Okay. Does anyone need any help?
Qui a besoin d'aide, on peut vous aider.
Yeah, obviously you can make the code cleaner, but we'll just do the simple things today.